In this video, I will prove that the cos of A minus B is equal to the cos of A cos B plus sine A sine B. So we'll start with this unit circle here. So the radius is 1. So we'll put in 2 radius there. Now, this angle here is B, which means that point must be cos B sine B. And this angle around to here is A, so that must be the point cos A sine A. Now, if that's A and that as far as here and B as far as here, well, in between must be an angle of A minus B, the difference of the two. So A minus B is right there in the middle. And the method for this proof is to get the length of a line segment here, from here to here. And we're going to get that distance using 2 different methods. We're going to get that distance using the cosine rule, which we have proved previously, and also using the distance formula. Now, if we use the distance formula first, we can call these points x1, y1 and x2, y2. So for example, this is the point x2, y2, and this is the point x1, y1. So get that distance between those two using the distance formula. So distance is equal to, from the tables, the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. And square both sides, it's easier, so just get distance squared is equal to, get rid of the root straight away, x squared minus x2 minus x1 squared plus y2 minus y1 to be squared. And now fill in those two. So x2 minus x1 is cos A minus cos B, as you can see here. So that's cos A minus cos B to be squared. And the same for the y's, it's sine A minus sine B. And that's squared as well. So there's your d squared. And now multiply out those brackets. So it's d squared is equal to cos A minus cos B squared, which means multiplied by itself. So write it down again. And the same over here, plus sine A minus sine B multiplied by itself because it's squared. And now multiply every term in this bracket by every term in this bracket. So it's first by first. Cos by cos is cos squared A. Cos by minus cos is minus cos A cos B. And this one here is minus cos A cos B again. And minus by minus is plus cos squared A. And do the same with all these over here. So it's sine A by sine A is sine squared A. So just take your time with this and multiply out term by term. Sine squared A minus sine A by sine B is sine A sine B. And again, minus sine A sine B here. And finally, minus sine B by minus sine B is plus, minus by minus is plus sine squared B. Now, to tidy all that up, start matching things together. For example, there's a cos squared A and a sine squared A here, which is 1. There's a... Actually, this should be a cos squared B. Just change that. That should be a cos squared B there. And then we have a cos squared B and a sine squared B here. So match those two together. That's also 1. From previous proof, we know the cos squared plus sine squared is always 1. And we also have minus cos A cos B here. Minus cos A cos B is minus 2 times cos A cos B. And we have minus sine A sine B. Minus sine A sine B is minus 2 sine A sine B. So tidying up further, you get 1 and 1 is 2 minus, take out the 2, there's a 2 common here and here to both terms. So take out the 2 outside and you get cos A cos B. If you take out the minus, it's plus sine A sine B. And that's it. That's as far as we can go with d squared there using the distance formula. So we've now got that distance squared. Now what we're going to do is get the distance squared again using a different formula, which is the cosine rule, and put both answers together. That's the method. So use the cosine rule this time. So using cosine rule, so we're going to get distance again. So distance squared is equal to, well, the cosine rule says the other two sides are squared. So we'll call those other two sides, well, what are they? Distance squared is, if we write down the cosine rule first maybe, a squared is equal to b squared plus c squared minus 2bc cosine of a. So there's the cosine rule that we have proved previously. Would fit it in for this particular triangle. So in this triangle, A is D. The distance we're looking for is D. So it's D squared is equal to B squared plus C squared, which are the other two sides squared. In our case, that's 1 and 1. It's a unit circle, so both of those other sides are 1 and 1. That's D up there. So D squared is equal to 1 squared plus 1 squared. And the rest of the formula is minus 2 times BC, which is 1 by 1, by the cos of the angle A, which is in between. The cos of the angle opposite the side A, in our case opposite the side D. And if you go back up, the angle opposite D is A minus B. So that's what we've just done. Is we have got the distance D using two different methods, the cosine rule and the distance formula. And we end up with these two formulas, distance squared here using the distance formula, distance squared here using the cosine rule. And if you tidy up one more step, you'll see it's even more obvious. 1 and 1 is 2, so you get 2 minus 2 cosine A minus B. So now the link between the two is obvious. If you look at the two formulas, d squared, 2 matches up with the 2, the minus 2 matches with the minus 2. The only difference is what's in the bracket here. So that must match up as well. So what's left over here must match with what's inside the bracket here, because everything else is the same as well. And that's it. That's the proof. That's what we're trying to prove. So that implies that the cos of A minus B is equal to cos A cos B plus sine A sine B. And that's the end of the proof.